Hello students, today we are going to study introduction about game theory. So first we should know what is mean by competitive situation. So many practical problems require decision making in a competitive situation where there are two or more opposing parties with conflicting interest and where the action of one depends upon the one taken by the opponent. So, for example, candidates for an election. So, in an election, a candidate is selected by one party first. Then, depending on that candidate nature, popularity, wealth, so many categories, the candidate for next party will be selected. Similarly, the countries involved in military battles. So, if one country is going with a certain type of weapons, based on that the opposing country also select some kind of weapons. So the selection of one strategy of one player depends on the selection of the strategy of the another player. So with this situation, we have to define what is meant by a game. So a competitive situation will be called a game if it has the following properties. So what are all the properties means? There are a finite number of competitors. So we have only a finite number of competitors. So that is our first property. Each player has a finite set of strategies, that is alternatives available to him. So each player has some alternatives available to him. With that strategies he is going to play. And then a play of the game takes place when each player employs his strategy. Afterwards, every game results in an outcome. So we have some outcome, either maybe loss or gain or draw. So usually these outcomes are known as payoff to some player. So under this situation, one competitive thing has happened, then we call that competitive situation as a game. Afterwards, we should know what is mean by a two-person zero-sum games. So games having the zero sum character, that the algebraic sum of gains and losses of all the players is zero is called the zero sum games. So that character is present, then our game is known as a zero sum game. So that is sum of gain or loss of one player, players of all the players is zero. It is known as a zero sum games. The play does not add a single paisa to the total wealth of all the players. In many, it merely results in new distribution of initial money among them. Zero sum games with the two players. So what is meant by zero sum? The algebraic sum of gain and losses of all the players is zero. It is known as a zero sum game. If one zero sum game with the two players are going to play, then that game is known as a two-person zero sum game or rectangular games. So in this two-person zero-sum game, only two players are there. So the gain of one player is exactly equal to the loss of the other player. So this is the important character in two-person zero-sum game. So The gain resulting from a two-person zero-sum game can be represented in the matrix form, which is usually called a payoff matrix. So that gains resulting from a two-person zero-sum game is represented in one matrix format. That format is known as a payoff matrix. So if we go with some example, it is easy to understand. So we are considering a two-person coin tossing a game. So we are having two players and they are going to toss coins. So each player tosses an unbiased coin simultaneously. So both players are having coins and they are going to toss those things simultaneously. Here we assumed player B pays rupees 7 to A if head occurs and player B pays rupees 4 to A if TT occurs. So we are assuming like this. Otherwise, player A plays rupees 3 to B. That is one having head and another one having tail. Now that player A pay rupees 3 to B. So we assumed like this. So this is two-person zero-sum game. Since A wins 7 rupees, then automatically it denotes B loses 7 rupees. So algebraic sum of gain and loss will be 7 and then minus 7, which is 0. So it is a two-person zero-sum game. So we denote this one by this matrix format. So we are considering this is player A and this one is player B. So both have strategies. They are tossing one coin only. So they have either head or tail. Similarly, B also having head or tail. So previously we defined player B will pay rupees 7 to player A if head appears. So first situation, head and so this matrix is known as a payoff matrix. It is usually considered for player A. So this is payoff matrix for player A. So we are going to fill this matrix. So it is head and head. So both head appeared. Then B will pay rupees 7 to A. So this 7 is gain for player A. So we are marked this one with plus 7. Similarly, T and T, both coin shows T and T. Then player B gives rupees 4 to player A. We assumed like that only in our problem. So this is gain for player A. So it is denoted by 4. And for otherwise, so that is one coin shows head and another one shows tail. Then A has to give rupees 3 to player B. That means A is going to lose something. So this one is mentioned by minus 3. As well as if A has tail and B has head, then also A is going to lose 3 rupees. So A's payoff matrix has minus 3 entries in these two opposite diagonal elements. So this is a payoff for player A. We can write payoff for payoff matrix for player B by choosing negative sign with this payoff matrix of player A. So this is the strategies and they are going to adopt in this particular game, and this matrix is a payoff matrix for player A. So next we should know what is meant by a pure strategy. So a strategy is called pure if one knows in advance of the play, that is that it's certain to be adopted adopted irrespective of the strategy the other may choose. So that type of strategy. So in advance, anyone may know what is the strategy the opponent going to take, then that strategy is known as a pure strategy. So to solve this game theory, that is which player has to select which strategy for a particular game, we should know this principle, which is known as maximin and minimax principle. So we will go with this example. So we are having two players, one is player A and another one is player B, and A has three strategies, namely A1, A2, A3, and B has two strategies, namely B1 and B2. So as usual, this matrix is a payoff matrix to player A. So if this player A select this A1 strategy, so he is going to adopt this A1 strategy. Then player B wants to minimize his loss, because if he select B1 means he is going to lose 9 rupees. If he choose B2, then he is going to lose only 2 rupees. So that player B will want to minimize his loss. So here we have to choose minimum. So in row we have to choose minimum. So the next in problem we will discuss all those things. Similarly, if this player A select A2 strategies, then also if player B is going to select B1, then player B is going to lose 8 rupees, and if B2 is selected by B, he is going to lose 6 rupees. So among these 6 will be less. So B wishes to minimize his loss. Therefore he wants to adopt with this minimum strategy, that is B wants to adopt this B2 strategy. Similarly for third row also we can go. If we are considering in point of player B, so if player B select B1 strategies, so B1 strategies means here he gains, he is going to lose 9 rupees, 8 rupees and 6 rupees. So player A going to gain 9 rupees, 8 rupees and 6 rupees. So player A wants to maximize his gain. So in this he wants to adopt this A1 strategy. That is because that A1 only gives 9 rupees. So in this column we have to consider maximum. So likewise only we are having this minimum and maximum. So among these minimum, previously I told no, for row we are going to consider minimum, and for this column we are going to consider maximum. So these are all minimum thing which player B wants to go. So among that he has to select the maximum value. Similarly, from column maximum, player A wants to minimize his thing. So that principle is known as maximum and minimax principle. So using that we can find some value of the game. So that one is defined here. So first we are going to define saddle point, afterwards value of the game. So what is meant by saddle point? A saddle point of a payoff matrix is that position in the payoff matrix where compare the maximum of the row minima. Previously I told no, in row we are going to consider minimum. Among minimum we want to choose the maximum value. So maximum of row minima coincides with the minimum of the column maxima. So if these two terms are coincided, then that point is known as the saddle point, and position, that position is known as the saddle point. The payoff of the saddle point is called the value of the game, and is obviously equal to the minimax and maximum value of the game. So this is our thing. So we should denote maximum by V lower bar and minimax by V upper bar. Okay, so these two notations are used, and this definition is we need. A game is said to be a fair game if that V lower bar and V upper bar both are equal and that equal value will be 0. Then that game is known as a fair game. Similarly, a game is known as a strictly determinable if V lower bar and V upper bar both are equal and that equal value is equal to value of the game V. So all those are equal. It is known as a strictly determinable game. So these things we should remember to proceed further in this game theory. So we are going to discuss this problems. So the problem is determine which of the following two-person zero-sum games are strictly determinable and fair. Give optimum strategies for each player in the case of strictly determinable games. So our first problem is considering like this. So I am having two players, player A and player B, and this is a payoff matrix for player A. So player A has two strategies, so we are considering that is A1 and A2, and B has two strategies, namely B1 and B2, and the payoff matrix is given. So if A1 and B1 both are played now, then A will receive 5 rupees, and if A1 and B2 is going to play now, then A will receive 0 rupees. Similarly, the other terms are given here. So in this we have to go with row minimum. Previously we discussed, no? So if player A is going to adopt this A1 strategy, then he is going to gain 5 rupees and 0 rupees. So in that point, that player B wants to minimize his loss. So he is surely going with this B2 strategy only. So only for this row we are finding row minimum. So among these two, your minimum value will be 0. Similarly, if A2 is selected by player A, then he is going to receive 0 rupees and 2 rupees. So according to player B's point of view, he wants to minimize his loss. So he surely adopt this B1 strategy only. So for this row, the minimum is 0 is selected. And then similarly come to player B point of view. If player B wants to choose this B1 strategy, then player A will receive 5 and 0. So player A's wishes to maximize his gain. So he surely going to adopt this A1 strategy only. So maximum value for this column, which is 5. Similarly, if B is going to adopt B2 strategy, then A will receive 0 rupees and 2 rupees. So obviously A's wishes to maximize his gain. So he is going to adopt this A2 strategy only. So in this column our maximum value will be 2. So among this minimum we have to choose the maximum value, but here both the values are 0, so both are taken as maximum, and it is denoted by min is denoted by V upper bar, so wrongly mentioned as V lower bar. Anyhow, no problem. And among this maximum we have to denote we have to find the minimum, which is 2 here. So min among minimum maximum, which is 0, max. So among maximum minimum, which is 2. So both are denoted by these two letters. So obviously these two values are not equal. So previously we defined a definition, no? So both are equal. So V lower bar, V upper bar, all are equal, and that equal value is equal to value of the game, then the game is known as strictly determinable. But in this problem they are not equal, therefore the game is not strictly determinable. Similarly, we are considering another problem. Here also we are having 2%. So this is payoff matrix for player A. So as usual for row, consider with minimum. Why we are choosing minimum? I hope all of you know the reason for that selection. So 0 and 2 first row value. So minimum will be 0. Here -1 and 4. So minimum will be -1. And for a column we want maximum, so 0 and -1, so maximum will be 0. 2 and 4, maximum will be 4. So among minimum we want maximum, so that value will be 0 here, and among maximum we want to minimum value, which is 0 here. So one is denoted by upper bar and another one is denoted by lower bar. Here both the values are equal, and that two values are intersecting at one point. That point is known as the value of the game, so which is marked as the star. So this A1 strategy is going to adopted by player A, and B1 strategy is adopted by player B for better result, and value of the game will be 0. So all are equal, lower bar, upper bar, and value of the game V all are equal. So if all these values are equal, then the game is known as strictly determinable, as well as that value is here 0. Therefore the game is known as a fair game. So this is a fair game. So what is the suggestion we are giving in this case means player A should adopt A1 strategy. Similarly, player B should adopt B1 strategy to get the best result of this game. So likewise we can find a game is strictly determinable, fair, and value of the game. What are the strategies going to adopt by both players? All those things we can find. So if these V lower bar, V upper bar value of the game all are equal, then that particular point is known as the saddle point. So this point is known as a saddle point. So in this game, saddle point is present. So we can tell the strategies adopted by player A. So here we have to mention player A should adopt A1 strategy and B should adopt B1 strategy. So that is the final solution we are giving, since it has the saddle point. So without a saddle point we have to do some another method to find the strategies the players should adopt. We will see those things in next video. Thank you.